Okay, now we're going to add one final transformation to our sine and cosine graphs, and then we'll be finished with this material. The last thing we want to do is take our entire sine and cosine function and add some number to it. We're going to call that d, just going with our pattern a, b, c, d. And if you understood what we were doing in the previous video with phase shift and graphing using quarter points, this is a really straightforward addition. So now all we're going to do is take our graph and shift it up or shift it down. So the idea is we take our function, and if we add a positive number d, we're going to just shift the graph up by d units. If we subtract a positive number d, so if it's like a minus, like in this example here, if we're subtracting a positive number, then we're going to shift down by that many units. So the only thing that's going to change for our graph are the y values and the range. Okay, so now before, the range of a times the sine of something or a times the cosine of something was negative the absolute value of a to the absolute value of a. Again, remember we had to take the absolute value so that we were assured that this number was positive, and then we would have negative first, positive second. So now all we're going to do is add our vertical shift to our range. Okay, so now our range will be negative the absolute value of a plus d, negative the absolute value of a, or sorry, positive the absolute value of a plus d. Doesn't change anything else. So the amplitude is still the same, period, phase shift, all that is the same whether or not you have a vertical shift or not. So this is the only thing that changes. So it makes it really straightforward. We can just graph using the techniques we had before. Just keep in mind that everything is going to be shifted up or shifted down. So now we're not going to have this sort of balance across the x-axis where there's as much stuff above as there is below. Okay, so let's just go ahead and do an example here. So here I've selected negative 2 times the cosine of 3x plus pi over 2 minus 1. So here our a is negative 2, our b is 3, our c is negative pi over 2, because remember, we're thinking bx minus c. So c is negative pi over 2, d is negative 1. Okay, so in this case, our amplitude is going to be 2. So remember, we take the absolute value of a, that's our amplitude, because amplitude is always a positive number. This minus means that we're going to be flipping our graph upside down as well, but that will be evident when we start doing our quarter points. Note that our period is going to be 2 pi over b, and so our period is going to be 2 pi over 3. And since we're going to need it, I may as well note that a quarter of our period is going to be 2 pi over 3 divided by 4, which is 2 pi over 12, which is pi over 6. Okay. So when we do our quarter points, we're just going to be progressing at intervals of pi over 6, which is 1/4 of our period. And then our phase shift is going to be c divided by b. So that's going to be negative pi over 2 divided by 3 is negative pi over 6. Okay, so in other words, we're going to start our period shifted pi over 6 units to the left. So we're going to start it at negative pi over 6. So this fact that we're adding pi over 2, since we're adding the positive number inside the cosine, that means we're going to have a left shift. Okay, and then finally, our range well, if we did not have this minus 1, and we just had negative 2 times the cosine of 3x plus pi over 2, our range would just be negative 2 to 2. It would just be, negative the absolute value of a to positive the absolute value of a. So now we need to add that d, so we need to subtract 1 to both ends of our range, because we're shifting everything down by 1 unit. So now instead of our y's ranging from negative 2 to positive 2, we shift that down by 1, and now we're going to range from negative 3 to positive 1. Okay, so that's all the relevant information. So now let's go ahead and figure out the coordinates of our quarter points. All right, so our first quarter point will be at x equals negative pi over 6. When x is negative pi over 6, y is going to be negative 2 times the cosine of 3x. 3x will be 3 times negative pi over 6 is negative 3 pi over 6 is negative pi over 2. Okay, plus pi over 2 minus 1. Okay, so that's going to be negative 2 times the cosine of 0 minus 1. Cosine of 0 is 1. So this is going to be negative 2 minus 1. Okay, which is negative 3. Okay, looking at our next quarter point. Okay, so remember we start at our phase shift, negative pi over 6. We add a quarter of our period, which is pi over 6. So our next quarter point is going to be at x equals 0. Negative pi over 6 plus pi over 6 is 0. So then here our y will be negative 2 times the cosine of 3x is 0. Okay, so we're just going to have negative 2 times the cosine of pi over 2 minus 1. Cosine of pi over 2 is 0, so this is going to be negative 2 times 0 minus 1, okay, which is going to be negative 1. Okay, our next quarter point is going to occur at 0 plus pi over 6 is x equals positive pi over 6. So again, we're just adding intervals of pi over 6. So then here, y is going to be negative 2 times the cosine of 3 times pi over 6 is pi over 2. Okay, plus pi over 2 minus 1. That's negative 2 times the cosine of pi minus 1. That's going to be negative 2 times negative 1 is 2 minus 1. Is positive 1. Okay, then we have 2 quarter points left to do. Really, we have 1 to do because the last one should match up with the first one. Okay, so next we're going to add another pi over 6, another quarter of our period. That's going to take us to pi over 6 plus pi over 6 is pi over 3. Okay, or 2 pi over 6. So here y is going to be negative 2 times the cosine of 3x will be pi plus pi over 2 minus 1. That's negative 2 times the cosine of 3 pi over 2 minus 1. Cosine of 3 pi over 2 is 0. Okay, so we're going to have negative 2 times 0 minus 1 is negative 1. Okay, and then finally, To get the last quarter point, we're going to take the previous one and add another quarter of our period. So here the arithmetic is a little hairy, but we can get through it. You do have to be able to add fractions pretty well to do this quarter point stuff, because pretty much everything is going to be a fraction involving pi. So here we have pi over 3 plus pi over 6. Okay, so that's going to be 2 pi over 6 plus 1 pi over 6, or 3 pi over 6 is pi over 2. So in other words, our last quarter point occurs at x equals pi over 2. And here, y is going to be negative 2 times the cosine of 3x is 3 pi over 2 plus pi over 2 minus 1. That's negative 2 times the cosine of 2 pi minus 1. And that's negative 2 times 1 minus 1 is again negative 3. So there we have our 5 quarter points, x and y. One thing you should notice when you do this quarter point method, and this is going to be your check to make sure you're doing everything correctly, and this is why we like the quarter points. Whenever you plug in your x coordinates into your y, whatever is inside the cosine or sine function should simplify to first 0, then pi over 2, then pi, then 3 pi over 2, and then 2 pi. Okay, so you should always be calculating either the sine or cosine of first 0, pi over 2 pi, 3 pi over 2, and 2 pi. That's what makes this process really straightforward for us. Because really we're not doing anything too fancy. Once you plug the x coordinate of your quarter point in, you're going to be computing sine or cosine of one of these 5 quarter points for the original sine or cosine graph. So that's just something to keep in mind if you do these calculations and you get some weird number that's not 0 pi over 2 pi, 3 pi over 2, or 2 pi. That indicates you made an arithmetic error somewhere. Okay, so let's just finish up by putting this graph together. Okay, so we had our first quarter point at x equals negative pi over 6. Okay, also remember that over here, these are our x coordinates of our quarter points. It's very easy to lose track of that and use what we're taking the sines and cosines of as our x coordinates, but the x coordinates are over here. So our first x coordinate is negative pi over 6, and our y coordinate there is going to be negative 3. The next quarter point will occur at x equals 0, and y is negative 1. Okay. The next quarter point occurs at x equals pi over 6, and y is equal to 1. Okay. The next one occurs at x equals pi over 3, and y is negative 1. And then finally, x equals pi over 2 is the end of our period, and that has a y coordinate of negative 3. So if we connect these together, we get a graph that looks like this, and I'll extend it out a little bit just to remind you where the relative minima are. And then we can continue this on to get more of the graph if you wanted to extend it out for multiple periods. Okay, so notice a couple things here. First off, this looks like a cosine graph that's flipped upside down, because now we're starting at the bottom and going up instead of starting at the top and going down. Shifted to the left by pi over 6 units. It doesn't start along the y-axis anymore. It's shifted along in the negative direction. We see this shift down by 1 unit, because if we didn't have this vertical shift, this dashed line would actually be at the x-axis, because that's where our sort of negative and positive parts would be balanced. So here we've shifted the whole thing down by 1 unit. That's what the d equals minus 1 does. We see our range from negative 3 to 1. That's what we were expecting. We see our amplitude is going to be 2 because the distance from the lowest to the highest y is 4. Negative 3 to 1, that difference is 4. Half of that is 2. So again, that's kind of like the height of the wave going up and then going back down. Okay, so we see all the things we were expecting, and then we have our period that we were expecting as well. So this would be how you would go about graphing a sine or cosine function with all of the shifts.